Okay, so this week we're going to talk about reactions. So there are two types of reactions that you need to know. We have exothermic, which is the first one up here, and then endothermic. So exo, I want you to think like you're exiting a space or a room, exo. And when you're exiting a room, you're releasing energy. So in an exothermic reaction, energy, heat, is being released into the environment. And so, most often, a lot of the reactions that we look at, or the most common ones, are exothermic. So, if you have a campfire, the heat that's being released through that chemical reaction, through the breakdown of your fuel, your wood, is an exothermic reaction. Endothermic reactions are a little less common, but we perform them lots in the lab. And an example is if you have an ice pack. So those ice packs that you break and then they cool, that's an example of an endothermic reaction. When you break that ice pack, you're actually breaking a barrier inside the pouch, and then you end up having two different chemicals bind together and react. And in that process, we call that an endothermic reaction because heat is actually being absorbed. So it cools off versus heat being released. Another really common reaction that you'll talk lots about also in grade 10 is combustion. So combustion is where, and we talked about this kind of throughout our WHMIS symbols as well, because a campfire is a common example of combustion. And so combustion occurs when we have oxygen and it reacts with another substance that's called typically a hydrocarbon. So a hydrocarbon is something that contains carbon and hydrogen, and it's a fuel source. Okay, so when you put wood, logs on a campfire, those are all made up of carbon and hydrogen bonds, and you need oxygen present there in order for combustion to take place. Okay? Your products for combustion are always going to be the same, so you're always going to end up with CO2 and then water. And so even you and I, as we're sitting here, we're going through combustion. So we're breaking down the food that we're eating, we're going through cellular respiration, and as the products of combustion, when we're doing work, we end up releasing CO2, breathing out carbon dioxide, and we also produce some water. Okay? Corrosion is another common chemical reaction that we see in our day-to-day. So it's a slow process, but again, it also occurs when, or it needs to occur when oxygen is present. Okay, and so it's really common in a lot of the different metals that we use, like iron, because they'll end up rusting. And so when they're in the presence of oxygen for a long period of time, we'll end up having what we call corrosion take place. And so corrosion actually breaks down those metals. And so it can be dangerous, especially depending on what we're working with and the stability that we need to have that structure. So it's really important that we're cognizant, that we're thinking of, is corrosion, is rust taking place? And you guys might notice things when they start to, the hinges on your door might get a little squeaky. And so those are all processes of corrosion, and so they're rusting. When we're looking at formulas, okay, some things that you guys are going to do a lot of in grade 10 is writing chemical formulas, taking word equations and writing the chemical formula, and also balancing chemical equations, which we won't do in grade 9, but you'll do in grade 10. And so just an important thing that we always need to know is that when we're writing reactions, chemical formulas, we're always going to have our reactants, so the things that are reacting on the right-hand side of, the left-hand side of your formula, and your products, what's being produced, the new substance, is always going to be on the right-hand side. So you're always going to have your reactants. I write it for you. And then your products. Okay. And so your reactants are always going to be on your left, and your products are always going to be on your right. And think of it like you read. So you read left to right. Okay. The arrows, okay, it's like an equal sign. We call it a yield sign as well. So it's yielding. This is the outcome, what's produced. And so these arrows always have to go left to right as well. Okay, just like you read. So it's a rule. Cannot just reverse the direction of the arrow. Okay, so it always has to go left to right. And especially in grade 10, you'll say, or your teacher will say, you have your reactants and your products. So they're very important terms to know. Reactants are the things on the left-hand side that are going through the chemical reaction, and your products are what's produced. And typically they're compounds, okay? And they're going to be on the right-hand side of your formula or your equation. So these are states of matter, and states of matter are going to become really important in Chem 20. In grade 10, you do touch on states of matter, and you're going to look at whether certain things are able to dissolve in water, certain compounds, certain metals or materials. You'll see if they're what we call aqueous. So aqueous, AQ, if you might have seen it in some formulas or in your readings, it means that that compound, that substance can dissolve, break down in water. So it's in a solution, okay? Common ones, gas. So all your non-metals on your periodic table, everything on the right-hand side, those are all gases. Then we have liquids. There are only a few liquid elements at room temperature, okay? So I'm not saying that you can't take the majority of the elements and put them into a liquid form. You can, but at room temperature, if you look at your periodic table, one of the common ones is mercury. And so mercury is actually liquid at room temperature, which is kind of unique because there aren't very many elements that are liquid at room temperature. Lots of solids at room temperature on your periodic table, and so it's just represented with an S. And those solids mostly are all your metals. Those are all solid at room temperature. Okay. So earlier on, I was going to get you guys to watch this video about different types of reactions, just comparing exothermic and endothermic reactions. And then I'm going to get you guys to watch a law of conservation of mass video. So what this video means, or what law of conservation of mass is that we cannot create or destroy matter. I can't just have it come out of nowhere. And when I have materials going through a chemical reaction, they don't just disappear. So whatever I start with is what I have to end with. I have to end with the same amount of mass, okay, material. And so nothing ever disappears, even though it might seem like that. So an example is like when I have a campfire, I have these large pieces of wood, and they're obviously large in mass. And when I set the wood on fire and it goes through a chemical reaction, at the end of it, it seems to appear like I have a lot less stuff in that area. I'm just left with a bunch of ash. But with the law of conservation of mass, what's important to note is that if I were to weigh my campfire, if I had it in a sealed container, so if I have, this is just going to be a before and this will be an after. So if I have my campfire in here and my logs of wood, okay, and if I were to weigh it, let's arbitrarily say it weighs 5 grams. Wouldn't make a lot of sense, but let's say it weighs 5 grams right now. So it's on a little scale, and I set my wood on fire. And by the end of it, I'm just left with a bunch of ash and maybe some smoke. Okay? This container would also still weigh 5 grams, even though to us, it doesn't really make a lot of sense. You had a bunch of heavy wood, and then now you've burnt it, and it's gone. Where did it go? All that matter, all those different elements, those carbon elements, the hydrogen, the oxygen, that's all there. That's all needing to be present. is all still in that container. It doesn't disappear. So I can rearrange how elements or atoms or molecules are all formed, but I can't get rid of them. They don't disappear. So that's a really important concept, especially in grade 10, when you look at balancing chemical formulas. So you'll have to make sure that what you start with on your reactant side, what's reacting, is the same in amount and quantity as your product side. Okay? And so that's something you don't balance chemical formulas in Science 9, not too much, but you will look at balancing them a lot in grade 10. Okay, so this is what a balanced chemical formula would look like. Okay, so what this means is what you start with on your reactant side. If you see nitrogen here, and you have this subscript 2, that little 2 means you have 2 atoms of nitrogen. On the other side, when you looked at the compound, your products, initially you would have seen NH and then 3 with that subscript. And what you do in balancing is you actually add what we call coefficients, these large numbers here. You might have heard that term in math. And so coefficients are numbers that will actually affect the whole compound or the rest of the formula. And so with this 2 here, this large 2, it's called a coefficient. If I add this 2 here, I've balanced my nitrogens. So I have 2 over here, and initially I only had 1. I have an invisible 1 there. So it's not balanced. I have 2 and then 1. What I start with, I need to end with. So if I add a 2, a coefficient in front of the nitrogen, it actually multiplies by that invisible 1. And so now I have 2 atoms of nitrogen. So I start with 2 and I end with 2. If I look at the hydrogen here in my reactants, I have hydrogen and then a subscript of 2. So I have 2 atoms of hydrogen. Over here, I've added that 2, and I had 3. So I had 3 and 2. That doesn't work. So I need to balance it. So if I add still that coefficient, I'll go 2 times 3 is 6. So I have 6 hydrogen atoms now. And over here, if I add a 3 coefficient to my 2, 3 times 2 is 6. Okay. This isn't a concept that you have to stress or worry about in grade 9. But it is something that you'll go into a lot of detail and you'll do lots of practice in grade 10. Okay? But so just understand the importance of the law of conservation of mass. Okay? And so it's important because what we start with, okay, when we're writing formulas and we're doing chemical equations and looking at reactions, what I start with, I have to end with in my products. Okay? So, so in addition, I'm going to have some textbook readings for you guys that will kind of go into a little bit more in depth about the law of conservation of mass. Law of definitive composition is a concept that you would have to know more or less for your PAT. So I'm not going to worry about it. But what it means is that certain compounds are always going to be, they're always going to look the same. They're always going to be in the same type of ratio. So if you're looking at a water molecule, okay, a water molecule is always going to have, here it says, oxygen and hydrogen bound together. And it's always going to be 11% hydrogen and 89% oxygen. And that ratio, that percentage will never change. So it's always 11% hydrogen, always 89% oxygen. And so we call that fixed proportions or a fixed ratio. And so it just means that if you're looking at water, you know exactly what you're looking at, 11% hydrogen and 89% oxygen. And that never changes. If it were to change, then it would probably be a different compound. Something else would be going on there. So it's a concept that we really only go over or review in grade 9 because of your PAT. So I wouldn't worry about it. You might see it in your textbook readings. But other than that, that's Unit B. Okay, so you guys have a great week. See ya.